So, welcome, boys. Due to COVID-19, we are suffering a huge gap between our live classes. So, I'm going to deliver a lecture on relation. Okay, this is our first lecture, class 12th mathematics, and I'm going to start relation. So, first of all, we are talking about the definition of relation. So the definition of relation is a relation R from set A to set B is always be a subset of its Cartesian product. Its Cartesian product. That is, R is always be a subset of A cross B. Okay? If R is a relation from A to B. For example, if I'm talking about a relation, so as we know that whenever we write a set, then we can write the set in two forms. One is set builder form, another is roster form. So the set builder form of a relation, we can say a relation R is x comma y such that x is a student of y. Okay, this is a set builder form. So now we nominate any class for class 11th PCM, the domain of class 11th PCM. This is a relation from set A, where the set A, the all element x are connected to set A. Okay, and the set B is the set of teachers. The set of teachers. So if there are a lot of stars, you can say star 1, star 2, star 3, star 4, star 5, star 6, star 7, star 8. And there is some hashes, you can say hash 1, hash 2 and hash 3. Okay. If this hash, you can say the teacher of physical education. Okay. And this hash denoted the teacher of computer science, and this hash denoted to the teacher of, you can say, Urdu or Hindi. So there are class 11th students. You know that these are subjects which are subsidiary. It is not compulsory subjects. So some star assigned to physical education and some star assigned to computer science. For example, if I said okay, these three stars goes to this hash. Why? Because these three stars selecting as an optional physical education, and these two stars selecting computer science as an optional, and these three stars selecting Urdu or Hindi as a subsidiary. So this is a relation between x and y, where x related to y with some definition, but this definition must be belongs to its Cartesian product. For example, I'm just elaborate this definition from another example. This is example second. If this is first, I said a relation R is x comma y such that y is equal to 2x minus 1. Okay, and x comma y belonging to set A, where set A is a set of natural number from 1 to 10. Okay, so if I'm talking about that relation, so that relation is always be a subset of A cross A, where how many entries of A cross A? Obvious, 1 to 10, 1 to 10. It means the number of total entries in set A cross A are 100. So whenever I write down the definition of relation, the relation will always be a subset of A cross B. It means if I am going to write any kind of relation, this relation must be a subset of its Cartesian product. For example, if I said x comma y, yani x related to y, this x y belongs to R means x related to y with some condition, and the condition is y is equal to 2x minus 1. So we have a domain. In domain, how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and in codomain, again 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then 1 goes to, so these are the element of A to B again, A to A, because this subset of must be a cross A. Okay, so the 1 goes to, then y is equal to 2x minus 1. It means you put, if x is equal to 1 is here, you got y as a 1. It means 1 related to 1. When you put y x is equal to 2, you got how much? 2 goes to 3. 3 goes to obvious 5. 4 goes to obvious 7. 5 goes to obvious 9. But for 6, 7, 8, 9 and 10, there is no entry in our that set. So the set builder form for that relation is, the roster form is 1 goes to 1, 2 goes to 3, and 3 goes to 5, and 4 goes to 7, and 5 goes to 9. That is, so that's the definition of relation. If you're talking about Cartesian product, then the Cartesian product of this set A cross A must contain R.